Hello everyone, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Now today in this video, I am about to discuss some basic concepts about dimension. Now the term dimension itself is a very vital term in all branches of mathematics, particularly in the study of geometry. In fact, the entire study of geometry stands on the concept of dimensions. Our entire universe and its matters can be studied in terms of dimensions. So let us start with the very concept of a dimension. That is what we mean by the term dimension. Now the very scientific definition of a dimension is much complex. It is not that easy to understand. But to explain it in easy words, we can define a dimension to be a parametric measure. It is a parametric measure needed to specify the position of a point on a given frame. So let me again repeat the definition. The term dimension may be defined as the minimum number of parameters or the minimum number of measures needed to specify the position of a point fully on a given frame. Now let me elaborate the concept behind it. So let us start with a straight line. Let us start with a straight line, a line. So if we are to locate a point anywhere on a line, on this frame, here our frame is a line. So if we are to locate the position of a point fully on a line, then what we have to do, first we have to consider a fixed point on the line. Anywhere on the line, first we have to consider a fixed point. That fixed point we refer to be the origin on this line, that is the origin. Now with respect to this fixed point means its position cannot change, the point cannot move, its position is constant on the line. Now with respect to this fixed point referred as the origin, we can now determine the position of another point which is a variable point, that is which can change its position with time, that is a moving point anywhere on the line, by measuring the distance between the two. That is with respect to some fixed point as origin, if we have a point anywhere on the line and if I measure the distance between the two and say the distance is x units, we may attach any scale factor, millimeter, centimeter, likewise, so the distance is x millimeter or x centimeter, whatever. Then this measure, by this measure we can locate the point on that line, and the origin we assign the constant 0 to origin and a positive constant to any variable point if the point lies on the right hand side of origin on the same line, and a negative constant with the variable point if it lies on the left hand side of origin on the same line. That is, for example, say we have a line with respect to some point as origin, some chosen point as origin. Now if a variable point lies on the right hand side of origin at a distance of 5 units from it on the right hand side, then the position of this point is specified by the real number plus 5. Whereas if the point lies on the left of origin at a distance of 5 units from it upon the same line, then this point is specified by the real number minus 5. and the origin itself is specified by the real number 0. So thus we see that whenever we have a point anywhere on a line, to determine its position with respect to some fixed point, that is origin, only one measure is sufficient. So therefore, dimension of a line is considered to be 1, because as I said, dimension means the minimum number of parameters required to specify a point fully on a frame, and here we see that one measure is sufficient enough to represent a point, or rather its position anywhere on a line with respect to the origin. A positive measure is attached if the point is on the right hand side, a negative measure is attached if the point is on the left hand side, and the numerical value of the measure gives the distance of that moving point from the origin. So hence a straight line is of one dimension. Thus, to locate any point on a line, one measure, one real number is sufficient enough. Now if I now pass on to the next level, from a straight line to a plane, you all must know the concept of a plane. What is a plane? Let me explain in short what is a plane. A plane may be considered as a surface. It is a surface such that if any two points are joined on that surface, say for example, let us consider this sheet of paper. Let us consider this sheet of paper. So this sheet of paper is a plane. Why? Because if you choose any 2 points on this sheet of paper on the surface, and if you join them by a line, by a straight line, then if each and every point on that line between these two chosen points also lie on the same surface, then that surface is referred to be a plane. So this is the definition of plane. This definition is given by the famous mathematician Euclid, and hence after his name we call it Euclid's definition. So what does Euclid's definition of a plane states? It states that a plane may be defined as a surface such that if we join any 2 points on that surface, any 2 points on that surface, if we join them by a line segment, then if each and every point of that line segment also lies on the same surface, then that surface can be considered to be a plane. For example, if I now consider the surface of a football, so this surface cannot be considered to be a plane. Of course it is a surface, but it is not a plane. Why? Because if you choose any 2 points on the surface of the ball, and if you join them by a line segment, then only the extremities lie on that surface, only the extremities, the extreme points, whereas all the intermediate points lie in vacuum. They are on air, they are not on the surface of the ball, they lie in vacuum. So hence the surface of a football cannot be considered to be a plane. So this is how we define a plane. Now how to find the dimensions of a plane? So here also the basic idea is the same, that as we know that this sheet of paper is a plane because it satisfies the Euclid's definition. So let me illustrate with help of this paper only. I shall be discussing all these things in details on a whiteboard with a marker in my upcoming videos, but right now I don't have the tools with me. So for sake of simplicity, let us consider this sheet of paper as a plane. Now to determine its dimension. So again, if I choose a point anywhere on this plane, anywhere you choose a point, now the minimum number of measures or the minimum number of parameters needed to fully determine its position will give us the dimension of the plane. Now to do so, what is the procedure? We consider two straight lines mutually perpendicular to each other. Say this one is the bottom corner line, the horizontal one, and the another one is the vertical one, this line, the vertical one, the vertical corner line. So these two lines, one the bottom corner line, the other one is the vertical corner line. So these two lines, they are perpendicular to each other, as you can clearly see that these two lines are at 90 degrees to each other. So the horizontal line we call the x-axis and the vertical line we call the y-axis. This is the x-axis, this is the y-axis, and the point where they intersect, this point is taken to be the origin. So this frame network is called a Cartesian frame. It is named after the famous mathematician René Cartesian Descartes, who invented this procedure to locate a point on a plane. After his name, it is known as Cartesian frame of coordinates. So here we have two mutually perpendicular lines, one horizontal and one vertical, intersected at the point origin. So here this is the point origin, and if we have anywhere a point on this plane, now we can fully determine the position of this point with respect to these two lines. How to do so? From this point, if you drop a perpendicular on x-axis like this, and also a perpendicular on y-axis like this, then the foot of the perpendiculars will lie on the respective lines, that is one on x-axis, the other on y-axis. If now we measure the distance of this foot of the perpendiculars, one on x-axis, the other on y-axis, dropped from this point, these are the two perpendiculars, these are their foots. So if now we measure the distances of these foots from the origin along these two axes, that is one, this distance, the horizontal distance, from this point we dropped a perpendicular upon x-axis, so here is the foot, so its distance from origin along x-axis, if I call this a, small a unit say, and again from this point we dropped a perpendicular upon y-axis, so here is the foot on the y-axis, so distance of this foot from the origin along the y-axis, this vertical distance, if I call it b unit say, so the horizontal distance is a unit, the distance of the foot of perpendicular on x-axis from the origin along x-axis is a units, and the distance of the foot of perpendicular from the point on y-axis from origin along y-axis is b units, then this point is denoted by the ordered pair a comma b inside first braces, a comma b. First we write a, then comma b, we enclose them within two first braces. So this is how we represent this point. The first point a is referred to be the abscissa, and the second point b is termed as the ordinate of this point, abscissa and ordinate, and together we call them coordinates. They together give us the coordinates of the point, and individually the first one is abscissa, the second one is ordinate. So this is how we can represent the position of a point on a plane. For example, say we have a point here. If we drop a perpendicular upon x-axis and the foot of the perpendicular is at a distance of 2 units from the origin along x-axis, and again from this point you drop a perpendicular on y-axis, the foot is at a distance of 3 units from the origin along y-axis, then this point is specified by the ordered pair 2, 3, first 2 then 3. What do we mean by ordered pair? Ordered means 2, pair means 2, and by order we means position, the positioning is important, which number is mentioned first, which number is mentioned second. So here by convention we always measure the horizontal measure, we always mention the horizontal measure first, and then we mention the vertical measure, that is the x measure, the distance of the foot of perpendicular from origin along the x-axis is always given first, and then the distance of the foot of perpendicular from the origin along the y-axis. So first abscissa and then ordinate. In this manner we represent the point. So now if I give you an ordered pair 5, 6, you can clearly locate the point. How to locate the point? Ordered pair 5, 6 means the x value is 5. So from the origin we move a distance of 5 units. So here we get a point on x-axis, and again from origin we move a distance of 6 units along y-axis. So here we get a point. So through these 2 points, if you draw 2 perpendicular lines, one like this and one like this, then the point where these 2 lines meet, intersect, that is the required point. We are just following the reverse procedure. So if the point is given, we drop the 2 perpendiculars upon the 2 respective axes and measure the distance of their foots from the origin, one along x-axis, one along y-axis, then we get his abscissa and ordinate. and if the abscissa and ordinates are given, we have to plot the point. In the previous case, the point was given, we determine its coordinates, that is the abscissa and the ordinate. Next is when the abscissa and the ordinate are given, say 2, 3, we have to plot the point. So first we move a distance of 2 units from origin along x-axis, we get a point here, and again we move a distance of 3 units from origin along y-axis, vertically above, we get a point here. So through these 2 points, if we draw 2 perpendicular lines, one like this and one like this, the point at where they meet, this is the desired point with coordinates 2 and 3. So here we see that to locate a point fully on a plane, minimum 2 measures are required. Why I am saying minimum 2 measure? What if I have only 1 measure? You may ask the same question, that what is the problem if I want to locate this point with 1 value only, say x value. Say if you say that let us drop a perpendicular from the point upon x-axis and this distance is x units. Distance of the point from x-axis, we drop a perpendicular from the point upon x-axis. This length is say 2 units, this is 2 units. Now you see, if I move this point parallel to x-axis, then I get infinite number of points, all of which lies at the distance of 2 units from the x-axis, because we know the distance between 2 parallel lines are constant. You know railway tracks, distance between 2 parallel lines are always fixed. So if we have a point on a plane at a distance of 2 units from the x-axis, that means from the point, if we drop a perpendicular on x-axis, the length of the perpendicular is 2, and if you move the point parallel to x-axis anywhere on the plane, then in each and every position it will satisfy the same criteria, that is the point will remain at a distance of 2 units from the x-axis. So the point is not fixed here, we have infinite number of such points possible. Likewise, if you consider the distance to be from the y-axis by the same concept, that let us have a point here, we drop a perpendicular on y-axis, this distance is say 3 units, and we say this is the point. Then here also if you move the point parallel to y-axis, then also we are having infinite points, each of which will have a distance of 3 units from the y-axis. So here also the position of the point is not fixed, we can have infinite number of points satisfying the same criteria. So unless we have 2 parameters x and y, the position of the point cannot be determined fully, because we have many choices. Then we cannot specify that this is the point, there are many other points satisfying the same criteria. But if we have abscissa and ordinate, both abscissa a fixed value, ordinate a fixed value, 2 and 3. So abscissa 2 from origin here 2 unit, from origin along y-axis 3 units. So if we drop 2 perpendiculars from here and here, draw 2 perpendiculars, we have a only fixed point, fixed intersection point. So then the point becomes fixed. So we require minimum 2 parameters to locate a point on a plane. So hence a plane is considered to be of 2 dimensions. Likewise, if I now proceed to the next level, that is a space, next higher level, space. Space means vacuum. So in vacuum, to locate a point, we require minimum 3 measures or 3 parameters. So hence a space is considered to be of 3 dimension. Now to do so, to locate a point in a space, first we have to get the concept of a 3-dimensional frame. We have to first form a frame, a 3-dimensional frame. Then only with the help of that frame we can locate a point in space. Now how to get a 3-dimensional frame? So here the idea is, say let us consider this sheet of paper as a plane, and say this corner line represents x-axis pointing towards you, this is the x-axis, and this point is origin. Then this line at right angles to x-axis, let us consider this line to be the y-axis. So this is x-axis, this is y-axis. So together they form a plane which we call xy plane, that is the sheet of paper itself, this is the xy plane. Now if I consider another straight line perpendicular, mutually perpendicular to both of these x and y, both of these x-axis and y-axis, if I consider another line, say if I consider this pen to be a line which is mutually perpendicular to both of them at the origin, like this. This is the x-axis, this is the y-axis, this is the origin. Through the origin we consider another line which is perpendicular to both x and y. So this third line we call it a z-axis. So here we consider three axes x, y and z. Likewise, we have three coordinate planes. These are the three coordinate axes x, y, z. So they form three coordinate planes. So this x axis and y axis, they form the xy plane, which is the floor or this sheet of paper xy plane. Now if you consider this x axis and this z axis, that is this pen, the x axis pointed towards you and this vertical line z axis. So they constitute a wall, a vertical wall like this. This is zx plane, and also the y axis with this z axis, they form another wall, vertical wall like this. This is the yz plane. So here we have three planes, one xy plane, one zx plane like this, and one yz plane. So three coordinate planes. So these three planes define a chamber in space. Chamber means a room sort of environment, a chamber, which we call an octant. So this is the concept of an octant in space. And later on in my upcoming videos, with the help of a whiteboard, I will explain that we can have 8 such octants possible, 8 such octants. This is only the first octant which I am stating here, which contains the positive x-axis, positive y-axis and positive z-axis. By positive x-axis I mean I can extend the x-axis backwards also. Here from origin, the line directed towards you is the positive x-axis. If you extend the line backwards, this is the negative x-axis. So we attach a negative scale to this portion. Similarly, from origin, if this is the positive y-axis, if I extend this the other way, this is the negative y-axis, and from origin, the line directed upward, if this denotes the positive z-axis, if I extend this below, we get the negative z-axis. So likewise, the three coordinate planes, xy plane, yz plane and zx plane, they are also extended in both ways. So finally, we get 8 such rooms, 8 such chambers, 4 in the upper portion with positive z-axis and 4 below with negative z-axis. Total 8 chambers or 8 rooms. Each of these rooms we call an octant. Now if I just confine my discussion in the first octant for time being, because I don't have the whiteboard now, so it's difficult to explain. So if I just confine my discussion in the first octant, if I have a point here in space, so how to locate the position here? There are many parallel methods available. Now the most simplest of all, or the most classical method, classical means the method which comes out from the very definition. Although this method is not used as a working rule, we use a different method, but this is the most formal and classical method. This states the concept is same, that say this is our x-axis, this is y-axis and this is z-axis, and we have a point here in space. So from this point, what we have to do, we have to drop 3 perpendiculars directly upon the axis. We have to drop 3 perpendiculars directly upon x, y and z axis. Likewise, say this is the x axis, here is the point. So from this point, we drop a perpendicular directly on x axis, say this pen. So obviously the perpendicular will fall oblique like that, but mind that this pen is perpendicular to x axis. It is a 3D frame. So from this point here is the x axis, here is the point, we drop a perpendicular like this directly on x axis, and here is the foot of perpendicular. Then we measure this foot from the origin, this distance, if this is a units. Similarly, from this point we drop a perpendicular directly on y axis, so the perpendicular falls diagonal wise, but is perpendicular to y axis. Here is the foot, we measure the distance of this foot along y axis from origin, and again from this point we drop a perpendicular directly on z axis. Here is our z axis. So from this point we drop a perpendicular directly on z axis, and again we measure the distance from the origin, this distance, this height. So if these 3 are A, B and C, then we represent the point to be the ordered triplet A, B, C. Ordered means again the position is important. First distance of the foot of perpendicular along x axis, then along y axis, then along z axis. So A, B, C. So here you see we require minimum 3 measures or 3 parameters to fully determine the point in space. The first one is called abscissa, the second one is called ordinate, the third one is called applicate, A-P-P-L-I-C-A-T, applicate. So hence a space is considered to be of 3 dimensions. So a line is a 1-dimensional frame, a plane is a 2-dimensional frame, and a space is a 3-dimensional frame. We have more than 3 dimensions also. Likewise, 4th dimension, time is considered to be of 4th dimension, although we cannot visualize for more than 3 dimension. Visual effects cannot be given for more than 3 dimension, but we have abstract study we have about n dimensions. We call that topological space, a space of n dimensions. I shall be discussing all those things one by one in my upcoming videos. Those are quite advanced level of discussion, but for time being we have 3 dimension, 1 dimension, 2 dimension and 3 dimension, up to which we can give visual effect. Beyond 3 dimension, visual effect is not possible. So what we mean by n dimension, if n is more than 3, what we mean by n dimension? The concept is exactly the same. It is just the generalization of the same concept. In 2 dimension, we have 2 mutually perpendicular straight lines passing through one fixed point, that is origin. In 3 dimension, we have 3 mutually perpendicular straight lines passing through a fixed point, that is origin. And in n dimension, a topological space of n dimension is considered to be a space where we have n number of straight lines mutually perpendicular to each other passing through the same point. So all concurrent lines, all of them passing through the same point and mutually perpendicular to each other. Mutually means pairwise perpendicular. Any 2 of them are perpendicular to each other. So this is not possible to diagrammatically express this thing, but we have such a concept of n lines mutually perpendicular to each other passing through the same point, that we call n dimensional topological space. Those are quite advanced level of discussion. In this video, let us confine our discussion up to 3 dimension: first dimension, second dimension and third dimension. So a line is taken to be a first dimension, a plane is considered to be a second dimensional frame, and a space is considered to be of third dimensional frame. All the objects around us are of 3 dimensional or of 2 dimensional. Maximum are of 3 dimensional. 2 dimensional means having only length and breadth, and 3 dimensional means having length, breadth and height as well. Now in this video, let us conclude here only. In our upcoming videos, I shall discuss some advanced concepts of some more concepts about dimension, that is n dimensional space. But to explain n dimensional topological space, one must know the concept of a vector. The concept of a vector is a vital concept to understand n dimensional topological space. That is a quite advanced level of discussion. But I shall be explaining in more details the 3-dimensional reference frame, as I was discussing about the octants, the 8 octants or 8 chambers, in my next upcoming video. I hope this video is helpful to you to understand the concept of a dimension and what is a 1-dimensional frame, 2-dimensional frame, 3-dimensional frame, and how we can locate position of a point on a line, on a plane and in a space. If you have any queries, you can ask me in the comment section. I shall try my best to answer that, and it will be of great help if you press the like button and subscribe to my channel. It will help my channel grow, and we shall be continuing with this topic in my upcoming videos. Thank you all for watching this video and wish you all a very good time. So we shall meet soon in the next video. Thank you all.